Hello and welcome to Unit 3, Lesson 10. We made it to the end. Well, what we're going to do today is put together all the things that we've learned during this unit. And we're going to look at these problems as puzzles, it says, polynomial puzzles. We're going to be given some pieces of information, and our job is to complete the puzzle, to find out all the missing pieces that we can. So you'll see as we go through, sometimes we'll be given roots, sometimes a factored form, and we'll figure everything out, including end behavior, domain, and range. So let's begin. Number 1 is given to us in factored form. Well, that tells us what the roots are. The roots are going to be the opposite of the factors. So x minus 1, that root would be 1. And x plus 3, that root would be negative 3. But since it's squared, that has a multiplicity of 2. Well, let's see if we can graph this. So we'll put down an x-axis and y-axis. And we're not going to get really technical on what the y is, but looking at the roots at 1 and negative 3, 1, 2, 3. The leading coefficient is the number in front, and that's a 2. So this thing has a positive orientation. It's going to come up from the bottom somewhere. And what's going to happen when it gets to negative 3? Well, it's going to bounce. It's going to hit that, bounce back, somewhere turn around, and then come back through that other root. Okay, so the end behavior, as you go far to the left, you're going to negative infinity. You go far to the right, you're going to positive infinity. The domain is all real numbers, and the range is all real numbers. So that's it. We've completed the puzzle. Let's look at the next one. Okay, now we're given roots. Negative 2 is a root, so we know that this function in factored form is going to be, well, let's do this. Before we do roots, look at the value of the leading coefficient, negative 2. So put a negative 2 to start with. Then our root is at negative 2, so we'll put x plus 2. And our root is at 1. That'll be x minus 1. But with a multiplicity of 2, that raises the power. So here's our x-axis. And here's the y. So this thing's going to go through negative 2, positive 1. It's the third degree. It says that here at the bottom. Third degree. And with a negative orientation, that means it's going to come from the top. Now, when it gets to that root at negative 2, it's going to cut through and somewhere turn around, come up and hit that root at positive 1, and then turn around and go back. So this one, end behavior starts at positive infinity, leaves at negative infinity. Now, how would we get the function in standard form? Well, that would be by multiplying it all together. So I'm just going to show you one of these, and then you'll know how to do it. So it says first you square x minus 1. So x minus 1 squared. And remember, last Ready, Set, Go, we learned a shortcut for this. This is x squared minus 2x plus 1. And then we're going to multiply that by x plus 2. So make a box. X and a 2. X squared minus 2x plus 1. Fill in the box. Okay, take it out of the box, combining like terms as you go. This is squared, so that's going to cancel out there. Okay, and that's almost the answer, but it does say that the leading coefficient is -2. So my function is going to be -2 out in front. And then, let's see. Oh, I made a little mistake. This is going to be -3x. Okay, so when the leading coefficient is -2, that happens because it got multiplied times this polynomial right here. So it's -2x to the third, but then it's -6x, and let's see, 2 times 2, 4. There we go. And actually, that's a plus here, because you have a negative over here, and then it's -2. Oh, wait, that would make this a -4 right here. There you go. What I should have done is I should have done this. -2 x cubed minus 3x plus 2, and then just, instead of trying to carry it over with my eyes, just distribute it. So on the future ones like this, I'm just going to tell you what the standard form is, assuming that you could multiply this together. Okay, let's look at number 3. So we don't have factored form, we don't have standard form, we don't have a lot of end behavior. We have some, but we do have the roots. And we have the leading coefficient of -1. Okay, and let's see, the roots. 3 with a multiplicity of 1. -1 with a multiplicity of 2. So that'll go to +1. And 0 with a multiplicity of 2. For 0 to be a root, you're just going to insert an x. I want to do it at the front. And square it because the multiplicity is 2. And don't forget the negative because of the leading coefficient. All right, now if you multiply all of that together to get back to the standard form, you would get -x to the 5th plus x to the 4th plus 5x to the 3rd plus 3x squared. So it's an odd degree. And we're coming through with roots at 0, 0, 3, and -1. So being odd degree, then if you go to the left, it says you're coming from above, you're coming down here, and as you go through the root at -1, since it has a multiplicity of 2, it's going to bounce off of this root, come back up, and then immediately go back down to this root at 0, but that has a multiplicity of 2, so you're going to bounce up off of that, turn around somewhere, and then you're going to go through the root at 3. Now, we don't say that that is absolutely the graph, but it's pretty close. And this is going to -infinity. The domain would be, again, all real numbers, and the range is all real numbers. On cubics, on odd degrees, that's usually what it is. I mean, unless you have some other restriction. And there are no restrictions here. Okay, number 4 looks like the letter W. So you got a bouncer here and a bouncer here. So that'll take care of the 4th power. So we can figure out the function. It goes through positive 2 and bounces. It goes through negative 2 and bounces. The end behavior is that it's coming from the top and it's leaving to the top. The roots are negative 2 with a multiplicity of 2 and positive 2 with a multiplicity of 2. Leading coefficient 1 and domain is going to be everything, but the range is going to only get down to 0, including 0, and go back up to positive infinity. Now, this other, where they said f of 0 is 16, well, that's this y-intercept right here. So they had a more accurate graph than we did on our previous ones, because we didn't really show exactly where the y-intercept was. Okay, number 5 introduces some imaginary answers, some imaginary roots. All right, so the roots are 2 plus I, 4, and 0, and an unknown root. Well, the unknown root is the conjugate of 2 plus I. It's 2 minus I. So here with our x-axis, and here with our y, we've got a root at 4. We've got a root at 0. And then you're not going to see the roots at 2 plus I and 2 minus I, but they will affect the behavior. Let's see, the leading coefficient is 1, and the degree is 4. And that means it's going to come from the top, it's going to leave to the top. So as a graph, it's going to come down from the top. It's going to turn around and squiggle around and turn around again and then come back through. So that when we count the degree goes 1, 2, 3, 4. And the function in factored form would be, let's get the real ones out of the way, x minus 4, x minus 0, or just x, and then for the imaginaries, x minus 2 minus I, and x minus 2 plus I. Okay, I think we've got it. Normally people would write this x out in the front. I just forgot. Okay, number 6. Now they're giving it to us in factored form, but they are giving us one of the roots. The root is at negative 2, and we're asked to find the other roots. So you know what that means is we should do division. We should do negative 2, and synthetic division coefficients are 1, negative 2, negative 7, and 2. So it's 1, and then negative 2, so negative 4, 8, and then 1, negative 2, and then 0. So what is left is x squared minus 4x plus 1 equals 0. Now, how do we find the roots from that? Well, quadratic formula will do it for us. So x equals negative b plus or minus the square root. This is not enough room here. Let's do b squared minus 4ac all over here. 4ac, so b is negative 4, a is 1, and c is 1. So that looks like 16 minus 4. Okay, so 12. All over 2 times 1. Now root 12 Okay, so if we look at root 12, that's root 4 times root 3, and root 4 is 2, so it's 2 root 3. X equals positive 4 plus or minus 2 root 3 over 2. Now all three of those can be reduced because 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 2 once. So our solutions are 2 plus or minus root 3. And that's the root here, 2 plus or minus root 3. That means that the function in factored form is that f of x equals x plus 2, the opposite, right? And then x minus 2 minus root 3, and x minus 2 plus root 3. I'm sorry about not being able to see that very well. They did not give us very much room for this. You can see from the graph, it comes from the bottom and it leaves to the top. The domain and range are all real numbers. Number 7. Okay, let's see. They've given us the function. Can we factor it? Well, we could take out an x, and that would be x squared minus 2. And then, can you factor x squared minus 2? Well, if you used solving techniques, you might set x squared minus 2 equal to 0. You might add 2 to both sides, and then take the square root. So you're going to get plus or minus root 2. So this could be x times x plus root 2, and then x minus root 2. And that's number 7. That's the factored form. That actually goes down here. Well, let's see. You can actually see the roots at radical 2 on a graph. Radical 2 is about, I think it's 1.4. So you have a root at 0, a root at about 1.4, and a root at negative 1.4. Now, this thing has a positive leading coefficient, so it comes from the bottom, cuts through here, turns around, comes back through here, turns around, comes through here. So the end behavior is that it comes from the bottom, leaves to the top. The roots are 2 and plus or minus root 2. Domain, all real numbers. Range, all real numbers. Well, we're going to go ahead and end it right there. This ties up Unit 3. It's been a pleasure. See you down the road.